Our next lesson in Chapter 2 looks at dimensional analysis. Dimensional analysis is a way to convert from one set of units to another using the units of our equivalents to sort of cancel out to go from one to another. So when we use dimensional analysis, we take an equivalent statement. So for example, that 1 pound is equal to 454 grams, and we turn these into what are called conversion factors. So a conversion factor will be a ratio of our units. So we can build two conversion factors from each equivalent statement. So we can have 1 pound per 454 grams, or we can have 454 grams per 1 pound. So because they are, again, equivalent, we can build them both this way. So this is important because depending on which direction we're going in our unit conversion, we're going to use one of those that will allow our units to cancel. So for example, kind of looking at this method here, if we had something that weighed 5 pounds and we wanted to see what that would be in grams, we would choose one of these two conversion factors to get our units of pounds to cancel. So in order to get units to cancel, we need to have 1 in the numerator and we need to have the same unit in the denominator. So if we look at our two conversion factors, conversion factor number 1 has pounds in the numerator, so that's not going to get our units to cancel. But the second one here has pounds in the denominator. So if we choose that one and have our 454 grams per 1 pound, then our pounds will cancel with our pounds here and we'll be left with units of grams. So if we put that in our calculators, we get 5 times 454 gives us 2,270 grams. Okay, so since we're in Chapter 2, it's also important to note that when we convert between units, we do consider our significant figures when we do these things here. So if we look, our 5 pounds, our first value here, this is a measured value. So if we look, we have two significant figures here. We look at the next step. This is a relationship between units. So we can consider our relationships between units to be exact, or they essentially have infinite number of significant figures. So if we look, our measured value only had 2. So we would want to report our value here to just 2 significant figures. So when we do that, we would have these 2 place values here holding our significant digits. So we're going to round. We'd have 2,300 grams. So if we look at this, these 2 zeros here we know are ambiguous. One way to eliminate ambiguous zeros in a number is to report it in scientific notation. So if we put this in scientific notation, we would show that these 2 digits are significant while dropping these placeholders. So if we put this in scientific notation, we would have 2.3 times 10 to the 3rd grams, where again, when we use scientific notation, we get to drop those zeros out of there. So that is how dimensional analysis works. Okay, so let's do a couple of practice problems. Okay, so kind of a recap of what we did. A in given units times the conversion factor with the requested units divided by the conversion factor, putting our given units down below. So the given units will cancel with the given units and give us our answer with the requested units. So we're going to be doing a handful of mathematical operations with units. So kind of a quick lesson on what units do when we multiply and divide. There's going to be some cases where we're going to multiply units together. So for example, if we had, say, the length of this paper, so up and down in centimeters, and we had the width in centimeters, if we multiplied those two together, we would get centimeters squared. So units multiplied by each other gives us units squared. If we were measuring a three-dimensional object, we could do centimeters times centimeters times centimeters to get centimeters cubed. And also we can divide units. So we saw this above where we had units in the numerator and denominator, and they divided out and canceled. So units can cancel, and again, units can multiply by one another. So again, we're going to choose our conversion factors just to get units to cancel. So if you always set it up and make sure that whatever unit you have, you put it in the opposite place. If your unit is in the numerator, you make sure your canceling unit is in the denominator. And we're going to see cases in just a minute where we're going to have units in a denominator. So again, we just want to make sure it's on the opposite side. So if our units were in the denominator, we would need to make sure their canceled units were in the numerator in our conversion factor. Okay, let's run through these sort of simple examples here. So we're going to convert 15 meters into kilometers. So identify the relationship between the units. Okay, so we need to know meters and kilometers. So you might know this, or if not, you can look in a metric unit table and know that the prefix kilo equals 10 to the third. That means you need 10 to the third of the base unit to equal 1 of the kilo. So what that means for us is we need 1 base unit, which is meters, to get, backtrack here. So our base unit is kilometers, so this goes with kilometers, so we need 1,000 of the base unit, which is meters, to equal the 1 kilometer. Okay, so this multiplier always goes with the base unit, and it equals 1 of the prefix here. Okay, so we're going to make the appropriate conversion factor now. So we will be going from meters to kilometers. So we're going to have our 15 meters. So for our conversion factor here, we can build it two ways. We can have 1,000 meters per 1 kilometer, or we can have 1 kilometer per 1,000 meters. So if we look at the operation we're trying to do here, we do want meters to cancel. So we're going to choose our conversion factor that has meters in the opposite place. So numerator, so we're going to choose it in the denominator here. So times 1 kilometer per 1,000 meters. So our meters cancel, and then we have our requested units of kilometers. So if you put this in your calculator, maybe you don't need to, but you can. So we get 0.015 kilometers. Okay, so let's look at our significant figures. So this is our measured value, the 15 meters. So we have two significant figures. So this 1 kilometer per 1,000 meters, this is exact. So we can count this as infinite. So we would want to report this to two significant figures. So if we look at what we have our 0.15 or 0.15 here, where the two zeros, those are just placeholder zeros. So we can leave the number like this because these zeros here we know are never significant. So you can leave the number like this, or if you want, you could use scientific notation to have your 1.5 times 10 to the -2 kilometers. Okay, so you could put this in scientific notation if you wanted to eliminate those zeros. But again, you don't have to in this case because here we know the zeros are never significant. Okay, next. So we are converting 1.54 pounds to kilograms. Okay, so in a table in your book, you might find a conversion to go straight from pounds to kilograms. I'm going to do it a little bit different just to show you another way that dimensional analysis is quite useful. So I'm going to identify relationships between the units. So up here they've given me that 1 pound is 454 grams, so I'm going to use that. Okay, so here I'm going to switch colors. Okay, so first I'm going to use, there we go, the 1 pound equals 454 grams. Okay, so that will take me from pounds to grams, but then I need to go to kilograms. But in this problem up here, I already used the prefix kilo, and I know that means 10 to the third. So the only thing that's different here is my base unit is going to change. It's going to be 1,000 now. Grams equals 1 kilogram. So we'll put this here as well. So we have our other 1,000 grams equals 1 kilogram. Okay, so we're going to use two different relationships between units, or we're going to build two conversion factors to accomplish this problem here. So a little bit different, but what is really nice about dimensional analysis is even if we needed to convert a couple more things, you can just string conversion factors one after another to get from whatever unit you have to whatever unit you need. That's really helpful if you are on a test and they've given you a conversion factor chart with some limited things on it. Okay, so let's start. So 1.54 pounds. Okay, so I'm going to build a grid. So since I'm going to be dealing with multiple conversion factors, so when I have this vertical line here, it's separating out my conversion factors, and this would be like multiply. So whatever this is, I'm going to multiply it by whatever number I put here. And now we have this line that represents the division. So then I'd be dividing by whatever goes down here. Okay, so we're going to go from pounds to grams first. So if we take a look, we want pounds to be the unit that is canceled. We're trying to get rid of pounds, so this 1 pound has to go in the denominator. So we're going to put our 1 pound here. And so then we know our 454 is going to go on the top or in the numerator. So the pounds will cancel with the pounds here. Okay, so now if we stop this problem, we'd have units of grams. They've asked us to go one more step and go to kilograms. So then we're going to use our second conversion factor and put it right here on the other side. So I want grams to cancel. I'm in grams, I want that to cancel. So I'm going to put my 1,000 grams in the denominator. And then my 1 kilogram will be in the numerator. So if we look at this next, the grams will cancel with the grams here, and the only unit left is my kilograms. Okay, so if you were putting this in your calculator, I would take my 1.54, multiply it by the 454. That gives me 699.16. So again, I'm not going to round until the very end. So then we're going to go to our next one. Then we're going to divide that by 1,000 to get 0.69916. And that is kilograms. So let's go through and look at what we have. Our measured value here has 3 significant figures, and we do know our relationships between units are infinite, so we're going to round to 3 sig figs, 1, 2, and 3. So we have the next digit here is a 1, so we get to round down. So we're going to keep this as 0.699 kilograms. Okay, so pounds to kilograms, we have 0.699 kilograms. Okay, so the next side is starting to look at what happens when you have units, say, in the numerator and in the denominator. All right, so it's not going to really change a whole lot. We're just going to have to stack our conversion factors one at a time to do our conversions here. So we're converting 25 miles per hour to units of miles per second. So when we set this up, we want our 25. So our miles are in the numerator, and we have 1 hour in the denominator. So this miles per hour means miles numerator, hours denominator. So we're converting from hours to seconds. So we're going to convert essentially just from hours to seconds here. Okay, so next, if we wanted to convert, let's think about how we can approach seconds. So we're going to have hours up here. So I know that in 1 hour, I have 60 minutes. Now my hours in the denominator are canceling with my hours in the numerator. And I do know that in 1 minute, I have 60 seconds. So then my minutes cancel with my minutes here. And we should be able to solve this for how many miles per second we're going. Okay, so for this problem, I'm going to have my 25. I'm going to divide that by my 60 minutes. Then I'm going to divide that by my 60 seconds. So I get 0.0069444. And my units here, so the miles never changed. So now I have miles. My hours were changed now to seconds. So that's miles per second. So if we go back and look at our original measured value, we have 2 significant figures. These are all infinite. So we're going to want to report 2 significant figures here, which would give us 0.0069 miles per second, which you could put into scientific notation if you want. Not required because, again, we do know that these zeros here, starting the number, are never significant. Okay, so this next problem, we're converting grams to ounces and milliliters to gallons kind of simultaneously here. So we'll have 10.5 grams per 1 milliliter. Okay, so we'll choose if we want to do mass first or if we want to do volume. Let's go ahead and we'll do the numerator first. So to grab these unit conversions, I use the one given in your textbook. So even though you do have an online version of this, this should be in your textbook, and I think I also have something similar to this in the modules for the course. So I grab that to get my my conversion factors here. So I found that, so we're trying to go from grams to ounces. So there's 1 pound equals 16 ounces, and there's 453.6 grams equals 1 pound, where I have one more significant figure for my grams pound conversion that I had on the other sheet there. Your book gave one more. Okay, so this, we can go from grams, we can turn that into pounds, and then we can turn pounds into ounces. So those 2 conversion factors will allow me to go from grams to ounces. Now I need to go from milliliters to gallons. So if I look again at your conversion factor, your table of conversion factors in your book, I found that 1 gallon equals 3.785 liters. Okay, so that will get us our gallon. And then to get our liters, we need to know what M is. So M is milli, and that is 10 to the minus 3. So we're going to build a conversion factor from milli based off of its decimal representation there. Okay, so we'll start with mass. So to go from grams to ounces, we'll start here. So grams is in the numerator, so I'm going to need to put my grams from my conversion factor in the denominator. So we'll put our 453.6 grams, and that's equal to 1 pound. So we use that guy there. So grams cancels with grams. Now we're going to turn our pounds into ounces with the next one. So that's here. So 1 pound. We're going to put the 1 pound here. And we're going to put the 16 ounces here. So pounds cancels with pounds. Okay, so if we put this in our calculator now, our units would be ounces per milliliter. So those are our 2 units that we still have. We have ounces, we have milliliters. Okay, let's keep going. So now we'll look at our volume ones. Okay, so I want milliliters. So I'm going to use this representation here, or this definition of milli. So milli equals 10 to the minus 3. This means that there are 10 to the minus 3 liters in 1 milliliter. So that number there, that definition, is telling you how many base unit you need to equal the prefix. So this is sort of the correct way of using the definitions from the metric prefixes, but in your book they probably have told you if you kind of take this out of decimal form, that you would get the 1 liter equals 1,000 milliliters. So either one of these two will work. So again, if you use the metric prefixes, this is what we would do. But again, if you use sort of milli is a very common one we use all the time. So you might have sort of already known this, so we can use that. Okay, so let's use that one there. So we have 1,000 milliliters is equal to 1 liter. So now milliliters cancels with milliliters. So now we have units of ounces per liter. So one more to get our gallons. So we're going to cancel our liters. So we're going to put our 3.785 liters. And we're going to put our 1 gallon down here. So our liters cancels with liters. So now if we look, our units that are left are ounces, and we have gallons, which is what the problem asked us for. Okay, so now it's just punching it into our calculator. Okay, so we have 10.5. We're going to divide that by 453.6. Then we're going to take that and multiply it by our 16. Our next step, multiply it by 1,000. And then we're going to multiply that by 3.785 to get 1,401. So it equals 1401 point, we'll call it 85. And that's ounces per gallon. Okay, so let's look. So we have 3 significant figures here. So again, all of these are sort of definitions or exact numbers. So we'll call those infinite. So we want to report this to 3 significant figures. That'd be 1, 2, and 3. So this would give us 1400 ounces per gallon. So now we're in the case where we definitely need to show that this 0 is significant, but this 0 is not. So just looking at the number here, you can't tell that. So we do have to put this in scientific notation to report that this 0 is in fact significant. So we're going to turn that into 1.40. So we're going to keep our 3 significant digits, 1, 2, and 3. That one gets to drop. And then we're going to put our multiplier. So we moved 1, 2, 3. So that's 10 to the third ounces per gallon. So this one here, we did need to put it into scientific notation to really show that we had 3 significant figures there. Okay, so our last sort of way that we're going to see units in dimensional analysis is when we have units raised to a power. So sometimes when we're converting from one thing to another, we're going to have to say convert in all 3 dimensions at one time. So when we do that, whatever sort of dimensions we're in, squared, for example, or in this case here, cubed, whatever it is that we need to do, we do that to the conversion factor. We have to do that to the number and the unit as well. So for example, if we have 1 inch equals 2.54 centimeters, if we were looking at inches squared and centimeters squared and we had to square these, we would get 1 inch squared equals 2.54 centimeters squared. And to show the connection between these two in 2 dimensions, we would get 1 inch squared equals 6.452 centimeters squared, where the 2.54 had to be squared and the centimeters had to be squared as well to get our conversion factor in units squared. Okay, so let's start here. We have 14,500 centimeters squared, and we want to turn this into meters squared. Okay, so we need just a regular sort of relationship between centimeters and meters. So centi equals 10 to the minus 2. So you can have 10 to the minus 2 meters equals 1 centimeter, or probably everyone knows 100 centimeters equals 1 meter. Okay, so we could use either one of those two. Most people opt for this one here. Okay, so if we're going from centimeters to meter, we want centimeters to cancel, so that's going to go down here. 100 centimeters, and then our 1 meter will be up here. So we want our units to be squared, so we're going to have to square and square. So 1 meter quantity squared is 1 meter squared. Down here, if we do this, we're going to have 100 squared, which gives us 1 followed by 4 zeros centimeters squared, where I've squared 100 and I've squared the centimeters here. Okay, so now when I do this, I'm going to use this number down here because, again, my units are squared. So when we calculate this out, we have 14,500 divided by my 1 followed by 4 zeros to give me 1.45. So after we solve this, 1.45 centimeters squared. Where if we look here, we have 1, 2, 3. These are ambiguous, so we don't count them to give us 1, 2, 3. Okay, so again, remember when we do this, we have to square. We want to get our units squared. We have to square the number in the conversion factor as well. Okay, so we'll get to do a lot of that in this last one here. So we're converting 19.3 grams per centimeter cubed to pounds per feet cubed. So we have 19.3 grams, and that's per centimeters cubed. And we want to convert that to pounds per feet cubed. So pounds per feet cubed. Okay, so we'll start with our mass because that one's easy. We've used this conversion factor a few times. So where we have 453.6 grams per 1 pound. Okay, so grams cancels with grams. So now we have pounds per centimeter cubed. Okay, so now we just want to convert our centimeters cubed into feet cubed. Okay, so if you look in any table of conversion factors, most of the time they give you, for centimeters, that 1 inch equals 2.54 centimeters. Okay, or we had that one up here in our description. So we can go from centimeters to inches, and then we can use that 12 inches equals 1 foot to complete this problem and get our feet here. Okay, so we're going to go centimeters to inches. So if we want centimeters to cancel, we're going to put that up here. So we have 2.54 centimeters for every 1 inch. So again, we have our units cubed. So we're going to take this and cube it. That gives us centimeters cubed. And then we have now pounds per inch cubed. Okay, so then our last one, going from inches to feet. So we want inches to go away. So we're going to put that up here. So we're going to have 12 inches cubed divided by 1 foot cubed. Okay, so before I put this in my calculator, I'm going to do just a couple of things. Just scoot over just a little bit here. Okay, so I want to know what 2.54 cubed is. Okay, so this is 16.387 centimeters cubed. And this is 1 inch cubed. Okay, now I'm going to do the same thing with the 12. So we're going to see what 12 cubed is. 1,728 inches cubed per 1 foot cubed. Okay, so because we had to cube those units again, remember that we do have to cube the number that goes with those conversion factors as well. Okay, so now we can put this in our calculator and we can solve. So we have 19.3. We're going to divide that by 453.6. We're going to take that and multiply it by 16.387. And then we're going to multiply that by 1,728. I did my 19.3 divided by my 19.3 divided by my 453.6, multiplied by my 16.387, and then to round it out, multiply by my 1,728. Okay, so when we do that, we have 1,204.83. If we look at our units that are left, we have pounds, and then our cubic feet. Okay, so let's look at our significant figures. So we have 3 that were given in the problem. Relationships, relationships, and relationships. So these ones are all exact or infinitely sort of significant. So we're rounding this to 3. So 1, 2, 3. So we got 1,200 pounds per feet cubed. And we end up in the same situation we were in for one of the problems above, where we do need to show that the 0 is significant. So we're going to turn this into 1.20 times 10 to the third pounds per feet cubed. So that is dimensional analysis. So we have kind of standard, simple dimensional analysis, straight unit conversion where you can string 1 or 2 or sometimes even more than that to go from one unit to another. We do have units can be in numerator and denominator. Again, the process is the same. Just make sure you line things up to get them in their correct positions to cancel. And then finally, we do have units raised to a power. So just remember when you set these up, if you need to square or cube a unit, you also need to square or cube the numbers in the conversion factor as well.